Hi team, today we're learning about trig identities. We've been learning about trig functions and today we're going to learn about identities. So the word identity in math is an equation that is always true. So there's some that are like trivially true, like who cares that x equals x, of course x equals x. Or there's some that are like useful when they're true, like Pythagorean theorem, a squared plus b squared equals c squared. There are a lot of trigonometric identities, but in this lesson and the next lesson, we're going to cover the ones that you're most likely to see and to use. Okay, so identities are things that we know to be true. Our basic strategy is going to be to convert everything into sine and cosine. So I'll show you a little bit about what I mean in our examples. So first things first, we got to know what the identities are. So as you might remember, secant is the opposite of cosine. Right? So it's called a reciprocal identity because it really means like 1 over cosine x is equal to secant. Right? So secant is equal to 1 over cosine x. We also learned that cosecant is the opposite of sine. Right? It's the reciprocal of sine. It's 1 over sine x. Right? These are our two here. And then tangent is interesting. Tangent is sine x over cosine x. If you think about it using the things that we've been working with so far, our x, our y, and our r, remember that sine x would be y over r, and cosine x would be x over r. Remember that when you divide two fractions, you're really multiplying by the second one. Maybe remember like keep, change, or copy, dot, flip, right? So this really right here, fix this y. This right here would be the same as multiplying times r over x. These r's would cancel, and we'd be left with y over x. Y over x, as you know, is tangent. So that is why tangent is equal to sine x over cosine x. That helps us because now we know that cotangent is the reciprocal of tangent. So we know that cotangent is 1 over tangent x, which essentially means that we are just flipping this fraction. Remember, reciprocal means the opposite, right? A flipped fraction version. So this cotangent would be equal to cosine over sine. Cosine over sine. So these are things that we're gonna memorize. You already have some of them like committed to memory, like sine and cosecant go together, cosine and secant go together. This one might be new for us. Tangent is sine over cosine. And that means that cotangent is equal to cosine over sine. So we're going to use these things to essentially recreate things that we already have, right? We're going to put them in a different like type of problem. So for example, since our basic strategy is we want to get everything into sine and cosine if possible, right? So since tangent x is here, I know that tangent is sine over cosine. So I'm going to exchange tangent for sine x over cosine x. This is currently being multiplied by cosine x. So I'm going to just bring cosine x straight down. Coming straight down. Now I can simplify my fraction. Remember, this would be like over 1 because it's basically a whole number. So cosine x over cosine x would divide to 1. Cosine x divided by cosine x is 1. So I have sine x times 1 over 1 would just be sine x. So the simplified version of tan x times cosine x is sine x. Right? So that is how we can simplify from 2 into 1. Let's do something similar with b. So I'm thinking, okay, with b, I have cosecant x times tangent x. Cosecant x, I know, is the opposite of sine x. So I'm going to go ahead and I'm going to turn that into 1 over sine x. So cosecant x is turning into 1 over sine. And then tangent, I know from the last one, is sine over cosine. Sine over cosine. So I turned tangent into sine over cosine. These are being multiplied together, which means that anything on the top can be divided by anything on the bottom. So sine divided by sine is 1. So I get 1 over cosine x. That is how I can simplify cosecant x and tangent x into 1 over cosine x. All right, let's take another look. Let's look at C. So when it says squared here, what it really means is there are 2 sine x's. So what I'm going to do is I'm going to write out both of them. I'm going to write out sine x times sine x. Right, so sine squared x is being there, and it's being multiplied times cotangent x. Remember, cotangent is the opposite of tangent, so it's cosine over sine. So I would have here cosine over sine. All right, these are on the top of a fraction because they are like whole numbers, right? So they're basically like over 1, like that. I can cancel one of the signs here with one of the signs here. So I'd have 1 over 1. So I'd have sine x times cosine x. It's over 1, but I don't need to write over 1. So this is my answer here, right? So we're basically just trying to take something more complicated and turn it into something simpler by using identities. Since these things are equal to each other, that means that I can exchange them and just write them in a different way. Let's try D. So tangent, I know, is sine over cosine. Right? When I say I know, it's one of my identities, right? One of the things we're memorizing. And cotangent is cosine over sine, right? So I know when I divide fractions, I keep the first one. Right? So the first one is sine x over cosine x. I change it to multiply, and then I flip this one to be sine x over cosine x. Right, so the top here becoming the bottom here becomes the top. I'm multiplying times the reciprocal. So when I get this one here, I'm gonna say, okay, I have sine times sine. That would be like sine squared x over cosine squared x, because I have cosine times cosine. You might recognize like, oh, this is sine over cosine, that's just tangent, right? So I'd say, okay, this is tangent squared x. Tangent squared. You might have noticed that from here, we had basically like tangent times tangent here. So another way you could have gone, instead of doing that, you could have said, okay, this is tangent x times tangent x. Tangent x times tangent x is tangent squared x. There's often many different ways that you can go about doing these. So if you do it a different way than someone else, that's totally fine. Okay, as long as you're getting to the same answer. As long as you're using identities that are true. All right, let's look at E. E is tangent. Feel free to pause if you feel like you're getting the hang of it. Tangent is sine over cosine, and it's being divided by sine. Remember, sine is like over 1, right? Sine x. So then I need to multiply times the reciprocal. So first I use the original one, right? So sine x over cosine x. That's my original one. And then in order to divide, I change it to multiply. And then I flip the second fraction. Flip the second fraction over. So I get 1 over sine x. Sine x on top, sine x on bottom. It's going to cancel. And I get 1 over cosine x. Remember 1 over cosine x, that's a reciprocal, right? Cosine is the opposite of secant. So I have secant x as my answer. Right. All right, let's look at F. All right, we have squareds again. So we have cotangent squared. Cotangent is the opposite of tangent. So cosine squared x over sine squared x. Secant is the opposite of cosine. So I'd have 1 over cosine squared x. Since this is squared, this is also squared. These are going to cancel. Cosine squared over cosine squared makes 1. This becomes 1 over sine squared x. 1 over sine, I know, is cosecant. Cosecant. So I'd have cosecant squared x. I'm going pretty fast because I have them memorized, but don't be afraid to keep your little cheat sheet open. That will be totally fine and it'll help you out in getting there. All right, let's do one more. This is our challenge problem for today. So remember, the goal is to turn things into sine and cosine. So I already have cosine x here. I'm just going to pull that straight down. Cosine x. Tangent turns into sine x over cosine x. So I'm seeing here that these can cancel. Leave me with just sine x. This one is 1 over cosecant x. I know that that is sine x. So I can convert this into that. And now I have 2 of them. If this was like sine x and cosine x, I would just leave it, right? That way I can just, my answer can have a plus sign in it. That's okay. Right, so sine x plus cosine plus, if it was sine plus cosine. Since there's 2 of them, you can actually write 2 sine x like that. And that can be your answer. It's kind of funny, but there are literally 2 of these sine x's. So this is our answer here. All right. So it's a lot of just like changing things into other things. Your goal, my basic strategy always is to convert everything into sine and cosine unless I see a shortcut or a faster way. So we'll work through these together today and let me know if you have any questions. Thanks, y'all.